Okay, and we'll get started. And hello, everyone. Good afternoon, and welcome to this training session. And today is about the SuperMap Image Pro product. This time, we'll have some slightly different compared to the last one. And in order to assess everyone's understanding, I will assign some practical exercises after the training, and that need everyone to complete. So the exercise quizzes will be conducted through on-site operation. There will be several tasks and will require you to take screenshots for each result. And you can zip all the screenshots and rename the zipped file with your name and send it to me. Okay, so let's start it. Before we proceed with the hands-on practice, let's first understand the product position and the capabilities of the ImageX. Our products integrates internationally leading photogrammetric algorithm, leveraging technologies such as the artificial intelligence, parallel acceleration, and cross-platform capabilities. It is designed to offer various image processing functions for remote sensing image data, and processes the capability to automate the production of data products. And next, let's take a closer look at the specific capabilities of this product. The first and basic capability is the image reading and management, covering the entire process from loading images to exporting them. And then is the capabilities of processing image. ImageX offers various processing functions related to raw images, such as distortion correction. In addition to this, it includes routine processes like image registration, mosaic, and also clipping. During the image processing, it also supports some common functions such as image fusion and image enhancement. And in practical image applications, image data production is essential, and our product provides a production process for the DOM, DSM, and also the ImageX Pro supports various types of satellite sensors. The commonly used satellite sensor ranging from low to high resolution can be accessed and read within the software. As for the data loaded in the software, we can check the coordinate systems and any other image information by open the image properties. We can also extract the image coverage by using the built-in tool in terms of acquiring image information. And ImageX can also provide a functionality to search for mosaiced image paths for the loaded images. Through this feature, we can identify which images in the processed data intersect with our study area and obtain the storage paths for those images. When managing image data, the software supports not only primary production but also manage the remote sensing products such as the authentication, and image fusion. And additionally, it allows for the management of thematic products that we have created. For the images that are read and managed, there's also support for the image image export. For example, with a multi-spectral image, we can export it as a true color image. After we understanding the capabilities of image management, let's now explore the image process capability of our software. And the first one is the radiometric correction. And here we use the spectral curve of vegetations as an example to demonstrate the effects before and after radiometric correction. It can be observed that the adjusted vegetation spectral curve has been brought into the normal range after the calibration. In addition to the radiometry correction, ImageX Pro also provides geometry correction. We can clearly see on these two before and after image that the geometry correction gives an excellent result, that the road is matched perfect compared to the reference image. And after completing image calibration, when using remote sensing image, it is often necessary to perform image registration. During image registration in the software, it supports the registration of both the multiple spectral and the panchromatic images, as well as registration based on the reference image. We can see the result before and after the registration are quite impressive. For the remote sensing images we acquire, it's often necessary to stitch them together to obtain an image of the study area. ImageX Pro provides the functionalities to create and edit mosaic lines, helping us to adjust the position of the stitching area for multiple images. For example, conducting the seam lines along the roads or rivers is done to avoid splitting buildings in the staging area and ensuring the accuracy of the subsequent analysis. And then ImageX Pro also has some general processing tools. For instance, that we can do image composite for the multispectral image, and then we can sort the display order based on the sequence of image addition or the image date. What's more, we can also clip the image by using our study area polygons. In addition to the aforementioned general processing options, ImageX Pro also supports the fusions of multispectral and panchromatic images. The multispectral images have rich spectral information but lower spatial resolution, while panchromatic image have high spatial resolution but lack spectral information. By using the ImageX Pro to fuse the two types of images, we can obtain a image with both high spatial and spectral resolution. What's more, our product also supports several image enhancement methods, such as image filter, image stretch, and image saturate adjustment. For the acquired stereoscopic mapping images, ImageX Pro offers the functionalities of automated production of DSM and DEM. This can be achieved by importing forward and backward-looking images to generate the DSM data. Subsequently, and the data can undergo filtering processes, and ultimately, DEM can be obtained based on the generated DSM data. And this process enables users to easily extract the surface and terrain models from stereoscopic images. And the above is the overview of the functionalities of our ImageX Pro. Next, I will demonstrate some of the features in the software. And so let's find some files. So these are two zip files of ImageX Pro software, and the remote sensing resource package is right here. Before we use the products, we need to first deploy the resources by unzip the files. And these are the unzip files that I have already finished before this meeting. And what we need to do is to open the remote sensing resources files, and we can see there are several folders. And what we need to do is to select all the folders except the bin folders and copy that to the package direction and find the resource. And then the remote sensing folders, and paste them to this direction. And then go back to the resource packages. And also copy the bin folders to our ImageX Pro root direction, which is right here. And for now, we finished the deployment, and then we can double click on the exe file. And this is our UI interface of the ImageX Pro. So, and the next step is to reading the image into this software. And what we need to do is to switch the view from this model window to the image map window, and we can right click on the source data, add raster, and you can see we can select the satellite sensor type, and this is the list of all types of the sensors that our products supported. And what we want to add is the super view one, number one. And there are two ways to add the data into this software. And the first one is from the folders, and we can find the our example data. It's right here. So this is our product package, and we can find the resources, remote sensing, and there is the example data that we just paste to the direction. And in the original folder, there is the data that we need to add to the software, and select them all. And all the multi-spectral and panchromatic image has been added to this list. We can select if we want to build an image pyramid, and here we check the box and click OK. And we can see our data has been loaded into the image map window. And we can also add some add the reference data by using the same way, like select the folder, and we can find our reference data from the same direction, remote sensing, example data, and here is our reference data. Select them all, and there's a list of all the reference data, and add them into the image map view. And then we can see the data has been loaded. So this is the step of our image reading. And the next step is to create the coverage and the footprints. So what we need to do is to find the tools in the toolbox bar, and we can find the image processing, satellite image reader, and here is the open image and batch load imaging. What we need to do is to right-click on this batch imaging and add them to a new model, which is right here. And then find the computer coverage, which is in the image processing, and then base image tools. And here is the compute coverage. Also drag it to the model window. Yeah, okay. And what we also need to do is to right-click on this other data source, and we can create a new data source to this place. Save it. We can replace the duplicate one. And our data source has been added to the list. And then double click on the batch load image, and we can select the file path. We need to find our original data of the super view number 1. And select the sensor category as super view number 1. And we can drag the result. When your mouse is become like this, you can hold on the results one and drag them to the compute coverage and set it as the source dataset images. And then double click on the compute coverage, and we can see the dataset has been added to this one. And our target data resources, we can set it as the data source. Rename the dataset name as and when you finish all the steps, you can click on the execute. And when the task management becomes to the 100%, our coverage has been added to the data source, which is right here. And you can right click on the coverage and add it to the image map. So here is the results of the coverage. We can cancel the reference data box, and we can see the coverage is like this. And for the footprint, we can also as the same way to as of the coverage, like right click on the batch load images and add the tools to the new model. And then you can find the compute footprints tools, also drag it to the model window. Double click on these batch load images and also find our original data. Set it as super view number 1 and drag the result to the tools, the compute footprints. Set it as the source dataset images. And then double click on the compute footprints. And we can also set the target data sources and the target name. And then click on the execute. And we can see the model has been finished. And we can also check the result on the image map. We need to first remove the coverage from the image. And then we can add the footprints to the image map. And this is the footprint of our data. So this is the end of the image coverage and footprints. And next is to create the image fusion. So by doing this, we need to create a new image map. We can close all these two models. And we can find the tools in the toolbox, which is in the image processing, satellite image, certification, and here is the batch fusion. So this is our tools, and what we can do is to open the uh, super view data from to the source data. Or stop right here is we can open the super view to the reference data by click the plus button and find the direction. Remote sensing example data, and there are two scenes of the super view data set, and the, for now we just need to open one of these and add the multispectral and the panchromatic data to the list and click on the OK. And for now, we only get one view of the super view data. And find the tools again and double click on it. And for the multispectral dataset, we can select this data. Click on this and click OK. And for the panchromatic dataset, click this one and add it to the list. For right there, we can select the caption fusion method, where we just leave them as the gram shin meet, and the resample method we can select as the cubic. The output direction we can set in the appropriate direction. And after we finish the setting, we can click on this execute. And Then we got the result, and we can check the result by right click on the source data and add the raster data, and then find the data we just created, which is right here, and open this data. And then we can see the fused data has not only the high spatial resolution, but also the spectral resolution. So this is the end of the image fusion. And the next one is the atmospheric correction. By doing this, we need to open the new image map. And then we can find the image processing, satellite image reader, and right click on the open image, add it to the new model. And then we can find the atmospheric correction tools, which is on the image processing, satellite image, radiometric correction, and capital atmospheric correction, and drag it into the model window. Right here, we can double click on the open image and find a data. For now, we need to we use the Galpin number one dataset uh, as the example, and we can open this one as well. So this sensor category is the Galpin number one PMS. Drag it to the capital atmospheric correction as the input image data. And we can find that this is the settings of the correction tools. And for the satellite image data we receive, it typically present in the DN value. So we just select this one, and then we can also check the atmospheric model box, so that we can automatically select the atmospheric models, and we can also set the output file path. And after the setting, we can click on the execute. And just wait several minutes um, the when we see the model's progress is 100%, and the result has been finished. So this is the end of the atmospheric correction. And the next one is the geometry correction. You can close the model right here. And for this new image map window, we can right click on the source dataset, add the raster, and this time we want to add the super view number 1 data, which is our example data. You can open we can open the this one, and here we can see their oh sorry. And here we can see there are two fused panchromatic data that we just created from the image fusion steps, and then we can add them to the source data. So this is our fusion data, and then what we're gonna do is to open the reference data by right click on this and add the raster and add image folder and find the resource remote sensing example data, and there's our reference data. Add them into the image map. Okay. And then we can create the connection point by using the geometry correction tools. We can find this one, generate connection points. Click on this. For the input, we just set it as the panchromatic image. And we can change the matching methods to the shift and then click on the OK. And we can see the result has been shown in the image map. So there is our connection points. We can also check out the point by clicking on the manage connection point. And here is the list of all the connection points. And we can click on the edit. So this is the edit window of the connection point, and we can select the single point to uh, so we can also add a new connection point or to edit the point that we get it. And we can also delete the connection point that we think is not very accurate. So after we finish the edit, we also need to click on the confirm point to save all your changing, and then close this window. Then we finish the connection point management. And for the next step, we need to generate a ground control point by clicking on these tools. And we can set the matching methods to the switch script and click on OK. We can close this attribute window table. And here is the result of all the ground control points. And the same as the connect point, we can also manage the ground control points by clicking on these tools. And we can also edit all the control points. Here a new window shows in the view, and we can also add or delete the control points, which is the same step as the connection point. So after we doing those connection point and the ground control point, we can use the block adjustment and set the result RPC direction to an appropriate direction. And right here, we just click on the OK button. The better way is to create new folders right there. And click on the OK. And then we finish the block adjustment, and we can check the result. And here is the text document, which is our summary of the block adjustment, which is like this. From there, you can check the more information about the uh, analysis result. And then after all the steps, we can generate the author photos. So right there, we just save our results to the training section direction, and we can create a new folder named DOM. So set the projection to the WGS 84, and then click the OK. And we can see the result is automatically shows in the image map. We can close all the other image, and this is our author photos. And this is the end of the geometry correction. And for the next one is the create mosaic data. And for this one, we can open a new image map window. And then we can right click on the other data source, and we want to create a new data source. And set file name as the site. Save it. And now we can right click on the mosaic data source and build a mosaic data set. Right there, we can open the author photo we just created. So just select all these two author photos, open it, and we can rename the data as the DOMs. And don't forget to set the target coordinate system to WGS 84 and click the OK. So this is our author photo DOMs, and you can add it to the image map to check if it is correct, which is right here. And then we can find the tools, which is in the image process, and then the mosaicing and the color balancing. And here is the build seam lines tools. Double click on this to open the tools. And For the data set, we can just set it as the DOMs, and and then and then we can just click on the execute. So after we finish after the tools progress has been finished, we can find here is the mosaic line is under the DOM's data, and we can also edit the mosaic data, and we can find this is the mosaic line between two images. And what we can do is to click on the on this line and click on edit node. We can try to edit the node to fit the road features like this. So after you finish the editing, you can right click on this map and to finish this uh, editing. And then after you finish all the settings, you can close this window, and then this is finish the mosaic line editing. And for the next step, there are still several steps of stitching the image. We can just double click on the stitching image and set the data sets as DOMs, and then find the direction to save the result. And then click on the execute. And after we finish it, we can check the result by open the result into the reference data. Right click on the reference data, and then click on the add raster. And find the result we just created. Open it. Click the open OK button. So here is the result of our stitched image. And so this is the end of the create mosaic data. And the next one is the image composite. By doing this, we need to open a new image map. And then we can find we can right click on this open other data source. And for now, we open the data sources that I just I have pre-prepared before this session. So in this data source, we have three bands of the Landsat 8 data, which we can see there's the band 4, 3, and 2. And what we want to do is to generate the uh, true color image. And what we need to find the image composite tools, which is in the data processing, and then raster data, and image composite. Double click on this, and then we can set the red band as band 4, green band as band 3, and blue band as band 2. And to save the result into the result image, the Landsat data source, and set the dataset name as the composite Landsat. And execute. And then we can check the result by right click on the composite Landsat 8 data and add it to the image map. We can see here is the result of the data. And this is the end of the image composite. And the last one is the calculate the normalized index. By doing this, we can open a new image map and right click on the reference data, add the raster data. For now, we would like to use the also the Landsat 8 data as the example. Here we can find the Landsat data. Here's the data 8. So to calculate the NDVI, we need to use the infrared band and the red band, which in the Landsat 8 is the band 5 and the band 4. We open these two bands to the reference data. Click on the OK. And then we can find the tools, the NDVI tools, which is in the data processing, raster data, and then the NDVI tool by double click on it and set the red band as the band 4 and near infrared band data as the band 5. And we can create a new data source. DVI, save it, create, and then we can click on the execute button. just wait for several minutes and after the progress is shows as the 100%, and the result we can check in the data source by we can check the result by right click on the result and add it to the image map. And you can see here is the NDVI result. And this is the end of the calculate normalized index and also the end of the training session. Thank you all for your attendance.